Hey kids, it's time for Speeding Around the Sun. This is going to be a big boy lab, as I like to call them, and it will have a lab quiz at the end. I don't think your sheets indicate that. So when you're done with this, you'll do your graph and your conclusion and come see us for a lab quiz. Yay.
Holla! Okay, so I'm not going to read the background information to you, but basically the whole goal of this lab is for you to get a clearer understanding of how the planet's distance from the sun will affect its period of revolution. Hopefully you have some ideas of how this will look, but now you're going to actually have some hardcore evidence to support your ideas.
Okay, so you should have the title and date down, and then now write the problem, which is also, it's sometimes called a problem statement, sometimes called a testable question. You need to be familiar with both. How does the planet's distance from the sun affect this period of revolution? Make sure you include a question mark since it is a question.
And also notice that your problem or testable question will always have the IV and the DV in it along with the word affect. So you should be able to identify which is which based on the problem or question.
Can you answer this with a yes or no, do you think?
No.
No scientific testable question should be a yes, no, or this or that, blue or red. It should be open-ended. That way you have to actually write a whole claim. Okay, when you're done with your problem, you need to write a hypothesis. How do you think the planet's distance from the sun will affect its period of revolution? So pause the video, write an if-then hypothesis, and don't tell me it will change. That's what I call wimpy hypotheses. You need to have one that has a specific thought with a specific prediction.
So not just the if-then, but make sure also that you include the IV and DV, and your hypothesis should be directional. So things like increasing or decreasing or more or less
or stay the same is fine.
Yep, are great directional terms.
Okay, so pause it. Okay, welcome back. Hopefully your hypothesis is great. You'll notice the materials here you have nothing new. If you don't have a stopwatch, we only have a handful in 7th grade. Your cell phone probably has a stopwatch feature, but I do have a couple, not very many, that you can borrow, or you can also use the clock with a second hand. However, the plastic tube indicated here, originally that's how we set this lab up. However, we can't find our plastic tubing. It disappeared over the summer. So we tried it, and it can work without the tubing.
All the materials you have there, the string has already been cut for you and attached to the rubber stoppers along with a washer on the other end. So while you have those materials, they're already assembled how they need to be.
Okay, procedures. So this is a model of a planet orbiting a sun, and that's what you're going to do. So I would encourage you to read the procedures.
Step 1 is already done for you, though. So the string has already been attached to the rubber stopper, and it is double knotted, but go ahead and pull on the string to make sure that the knot is still tight.
And then step 2 you can skip because we're not using the plastic tubing.
And the weight is already tied to it, so.
And now step 3 and 4 is we're going to start focusing when you, those are steps you actually have to do. So you're going to hold it over your head and keep the length of the string constant with your thumb and your index finger, and then you're going to start swinging just fast enough to keep the stopper moving. We do not need to prove your strength. We know you're super strong. We've seen it before, and we have no doubt that you're the strongest person in the world. However, we just want this to go fast enough to keep it going, so enough inertia to keep the orbit.
And in step 3, it tells you to pull the string so the stopper's 20 centimeters away from the plastic tube. Since you don't have a plastic tube, just measure 20 centimeters away and then put your hand where that 20 centimeters is, so that the length from your hand to the rubber stopper is the measurement that you need.
Okay, the purple caution is extremely important. When you're swinging this over your head, you need to stand away from other kids. You need to make sure it's not near a smart board or any technology. That it's just not going to hit anybody. And then just don't let go.
And please, please, please make sure that you are being responsible 7th graders with this. If we find out that you are hitting one another with the rubber stoppers, the lab will be over and no one will be allowed to leave the classroom like before.
Yep, been down that road. Okay, continuing on with the procedures, you're going to have a partner. If you're by yourself, it's totally doable. And with the second hand, you're going to time how long it takes the rubber stopper to make 10 complete revolutions.
Okay, make sure they're complete. So wherever you start the revolution until it gets back to that spot, it's not 1 until then.
And then to figure out how long it takes for 1 revolution, you just divide by 10 then, which makes sense.
So if you get 10 seconds to complete 10 revolutions, then your period of revolution is 1 second. Okay?
Look at her. Miss Voss and Miss Petrescu will be so proud. Okay, and then as step 7 and 8 indicate, you're going to do multiple trials, and you're going to do this for 40 centimeters and 60. So your levels of the IV are 20, 40, and 60 centimeters away from the tube, which is non-existent. You'll have a data table. You can draw this in your notebook. Notice I want straight lines, just like it indicates on that data table. They must have used a ruler. Whoa. So to pause the video, draw your data table. Okay, so what is this all about? You're having string in a stopper. I want you to remember that this is representing the solar system. So the sun is the center of the solar system, so it's where you're pinching it. And then as you put it 20, maybe that's Earth, and maybe 40 is Jupiter, and maybe 60 is Neptune or so. That represents the different planets at different distances. So this, I want you to make sure there's a real life connection here. And then finally, when you're done, there's 2 sets of things you need to do here. You'll notice that there's some analyzing questions. We want you to answer those analyzing questions using complete sentences. They're on your lab sheet.
You don't have to rewrite the question, but you do need to write incomplete sentences. None of this 3-answer questions. I mean, three-word answers.
Also, no it or that or they. What is it? The planet, the rubber stopper, the string, the boogeyman. Define the word it. No pronouns until you establish the noun. And then finally, your conclusion. And I want you to beef this up. 8th grade is asking for a 4th aspect to their conclusion. So you'll do the claim, which answers the testable question. You'll do, was your hypothesis supported? Of course, you'll have evidence. And by 8th grade, they'll expect you to have a real-world connection. So you need to take this a step further and explain how this connects to real-world applications.
And don't forget that when you're writing your evidence should actually have data from your lab in it. So it should include numbers. Don't tell us that 20 centimeters had the slowest revolution time. Give us actual numbers to support.
And then if 20 centimeters was 1 second, like she was saying earlier, what was 40 centimeters? How did that compare to the other one? Was 40 centimeters 1.1 seconds, or was 40 centimeters 20 seconds? We need to kind of be able to get some ground here and compare it. Okay, kiddos, when you're done, you'll show us your lab and then do the lab quiz. Any other thoughts?
No, just make sure you take your time on this because you should be getting pretty good at these labs. So when you take your lab quiz, we should be seeing a lot of PAs and A's.
Exactly.
Not anything below P's.
Later, skater.
Do work.